Hello students, I am Ramesh, your chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. In last class, we discussed about inductive effect and its application. Now, we may see the electromeric effect. Electromeric effect. What is that electromeric effect? And delocalization of pi electron. Delocalization of pi electron. Delocalization of pi electron in organic compounds containing multiple bonds. Contains multiple bonds. And here, for example, the multiple bond, that is one carbon double bond carbon, or carbon double bond oxygen, or carbon double bond nitrogen. So these are all multiple bonds. Now, what do you mean by delocalization? Delocalization is nothing but the electron is not present in a single atom. It will be moving. So that the movement of pi electron in organic compound contains multiple bond are called as electromeric effect. And this electromeric effect is temporary effect. So it is a temporary effect, not a permanent one. When the reagent is attacked on that substrate, then the effect will arises. So the reagent is added to the substrate, then the effect is present. If the reagent is removed, then the effect is vanished. So the effect is present only the reagent is added to that substrate. There are two types of electromeric effect. One is positive electromeric effect and negative electromeric effect. So we will take electromeric effect, and the electromeric effect is classified into two types. One is positive electromeric effect, that is plus E, and negative electromeric effect, it is minus E. And the positive electromeric effect occurs mostly in alkene and alkyne. So alkene and alkyne reactions, mostly positive electromeric effect is possible. Now minus E, that is negative electromeric effect, is mostly occur in aldehyde and ketones. So aldehyde and ketone mostly, that is negative electromeric effect. We may see one by one. So the first one, it is positive electromeric effect. Now, positive electromeric effect, here we may take here it will be occur only in a multiple bond. And the pi bond or pi electron is transferred to a particular atom, and the particular atom, the reagent is attached. So the pi electron is transferred to particular atom where the reagent is added. So the reagent is attached with the highest electron density. A reagent is attached with the highest electron density. For example, we may take, that is, in alkene and alkyne. Alkene and alkyne, most probably this positive electromeric effect is possible. Now, we may take a propylene, that is CH3, CH, double bond, CH2. Now, it is a propylene. When propylene is reacted with HBr, propylene is reacted with HBr, hydrogen bromide. Now, the reaction is, here the hydrogen and Br is attached here. So, we are getting CH3 and CH, Br and that is CH3. So, it is a correct product. It is a correct product. Then, why not the opposite is not possible? We may see later. Suppose, if the opposition, what is it? Hydrogen is going to the second carbon and bromine is going to the first carbon. It is not possible. Suppose, here CH3 and CH2 and CH2Br is not possible. Why? Because of inductive effect. What is that inductive effect? And here it is a first carbon and a second carbon and it is a third carbon. Now it is a methyl group, it is plus I effect. What do you mean by positive inductive effect? That is electron donating group. So these are all electron donating group. So what happened here? The pi bond will move towards that CH2, that is a second carbon. Here it is a second carbon, not CH2. And so the movement of pi bond towards the second carbon, so in second carbon the electron density increases. So what will happen? Here the electron density increases at the second carbon so that the pi bond will move towards the first carbon. So hydrogen is attached the first carbon, not at the second carbon. Now the reaction mechanism we may see, these reactions occurs in two steps. So we are take, that is step 1. Step 1. And what will happen in step 1? Here that is CH3 and CH double bond CH2 is attracted by the H plus. Why it is attracted by the H plus? Because of electron donating group, that is plus I effect. So the covalent bond electron density will move towards that the second carbon and that the pi bond will move here so that it will be occur a negative charge. So what will happen? The positive charge or H plus is moving towards the first carbon. So we are getting that here CH3 and CH plus and here it is CH3. So we may produce a carbocation. We may produce it is a isopropyl carbocation. Isopropyl carbocation. Now we may take that the second step. And step 2, here this isopropyl carbocation CH3, CH plus and CH3 is attracted by that this Br minus. Br minus. So we are getting that here CH3, CH, Br and that CH3. Listen, in your first step, H plus, that is positive charge. Positive charge is attached where the electron move towards the first carbon. So the H plus is attached to the first carbon. Then it is known as the positive electromeric effect. Listen, what is a positive electromeric effect? Here, in a multiple double bond of organic compound, the pi electron will transfer to a particular atom. That particular atom, the reagent is added. Now, you know that H plus is a positive charge. H plus, we may compare that the electrophile and the nucleophile. H plus is a electrophile. Electrophile. Now, Br minus, these are all nucleophile. Nucleophile. Now, it is electrophilic addition or nucleophilic addition. And it is always which one attack that first, then that is the electrophilic addition or maybe a nucleophilic addition. In this reaction, in a first step, the electrophile is going to attack the first carbon, so that this reaction is considered as electrophilic addition. Electrophilic addition, not nucleophilic addition. And in that second step only, the nucleophile, that is Br minus, is going to attack the carbocation. So, which one is first? Then we may consider, if electrophile is going to attack the first step, then it is considered electrophilic addition. If nucleophile is attacking on that first step, then it is nucleophilic addition. So, in the first step, electrophile is going to attack, so that it is electrophilic addition. Electrophilic addition. And also, this step, which is a slow step. So, here the first step is a slow step, and it is always considered as, in reaction mechanism, slow step is considered as rate determining step. Rate determining step. So, the speed of the reaction is dependent only the first step, not a second step. So, the speed of the reaction is dependent the slow step, that is a first step. So, first step is considered as electrophilic addition. Now, we may take the next compound. Here, it is 2-pentene. So, second compound, that is 2-pentene, CH3 and CH2 and CH double bond CH and that CH3. When 2-pentene is reacted with HBr, what is the product? Where the electron density is moved, then which one is going to attack? And I have always said, that is, in a alkane, electrophilic addition occurs, that is positive electromeric effect. Then there are two possibilities. The electron will move either here or will move either here. Which one is correct? If the electron move here, then hydrogen is going to attach here. And if electron is moving the opposite direction, hydrogen is attached the third carbon. Suppose we are taking the number 1 and 2 and 3, 4, 5. Now, the H plus is going to attack the second carbon or third carbon. How will you determine? And it is determined by the inductive effect. And either side of a double bond, there is two groups. What are the groups? One is methyl and another one ethyl group. We may compare the plus psi effect of methyl and ethyl group, and it is always ethyl group has maximum plus psi effect than that of methyl group. So, which one has maximum plus psi effect? Ethyl group. So, ethyl group has maximum plus psi effect. So, the bond pair of electron will move towards from fourth carbon to third carbon, so that in third carbon electron density increases. So, the bond pair or pi electron will move towards the second carbon, so that the product is, we are taking here CH3, CH2 and CH and here it is CH2 and it is positive, and here CH3 and it is reaction with H plus, and furthermore it is reacted with Br minus, so that here it is CH3, CH2 and CH, Br and CH2, CH3. So we are getting 3-bromopentane is a final product. So now what do you mean by positive electromeric effect? The positive electromeric effect is defined as, listen, the multiple double bond organic compound containing multiple double bond, and the transfer of pi electron towards a particular atom where the reagent is attached in the first step, then it is known as positive electromeric effect. So here positive electromeric effect or plus C effect is defined as the reagent is attached at where the electron density increases, then it is known as positive electromeric effect. Now the second one, it is negative electromeric effect. What is it? The negative electromeric effect. And here the pi electron is transferred to the highest electronegative atom. So the pi electron is transferred to high electronegative atom. And here the reagent is attached opposite to the electron transfer. So here the reagent is attached opposite to electron transfer. Then it is known as negative inductive effect. So we are taken, there is pi electron is transferred to highest electronegative atom, and here the reagent is attached to opposite to electron transfer. Now we may take that example. Here mostly aldehyde and ketone follows negative electromeric effect. And we have taken the aldehyde. Here it is R bond C double bond O and the H. That is aldehyde. When aldehyde is reacted with HCl, hydrogen cyanide. When aldehyde is reacted with the hydrogen cyanide, then it is a addition reaction of aldehyde. Now what will happen? Hydrogen will be moved here. Why the hydrogen is moving here? And comparing carbon and oxygen, which one has highest electronegative atom? Here the electronegativity, when carbon and oxygen has highest electronegative. Now the pi electron is a weak one, so the pi electron is transferred to oxygen, so it is getting a negative charge. Now carbon is lose its pi electron, so that it is getting a positive charge, so that here the H plus is attacked first. So we are getting that it is R and C OH, and here H, and that here it is Cn cyanide. So cyanide it is Cn minus, hydrogen it is H plus, so positive negative attraction. So H plus is attached with the oxygen and Cn is attached with carbon, that is carbocation. Now it may be occur in two steps. Now we may take that the reaction, that is step 1. What will happen? We are taking a aldehyde, that is R, C double bond O and that H. Then it is reacted with Cn minus. Cn minus. Why it is reacted with Cn minus? Here the oxygen is highest electronegative, so the pi bond is transferred to oxygen, so that it is getting a negative and positive, and Cn minus is a nucleophile. So here the nucleophile, that is Cn minus, it is a nucleophile, and the nucleophile is going to attack the carbonyl carbon. So the first attachment is nucleophilic addition, so that it is considered as nucleophilic addition. Nucleophilic addition. And here we may take the negative electromeric effect. And what is that negative electromeric effect? Here organic compound containing a double bond with the highest electronegative atom. Now the pi electron transfer to highest electronegative atom, and the reagent is attached opposite to electron transfer. Here the electron transfer from carbon to oxygen. Now the nucleophile or the reagent is attached opposite to the electron transfer, so that it is a negative electromeric effect. So we are getting, that is R bond C, and here H and O minus, and here Cn. Now it is considered as nucleophilic addition. Now second step we are taking, that is step 2, and we are taking that R bond C and O minus and H and here Cn, and it is attached with H plus. Now H plus is considered as the electrophile. H plus is considered as a electrophile. So first nucleophilic addition followed by electrophilic addition. Nucleophilic addition is followed by electrophilic addition. So OH minus is attached. So here R, C, OH and Cn and hydrogen. So it is aldehyde cyanohydrin. Aldehyde cyanohydrin. It is cyanide and hydrogen. So aldehyde cyanohydrin. So here first step nucleophilic addition. This addition is going to attach where the electron density decreases. So this negative electromeric effect is nothing but the reagent is attached where the electron density decreases. So here the reagent is attached in a first step where the electron density decreases, so that it is negative electromeric effect, and it is a temporary effect. Only in presence of reagent it is occur. And here we are taking that the electromeric, that is negative electromeric effect. Now this reaction is electrophilic addition or nucleophilic addition. Now here the first step is nucleophilic addition and the second step is electrophilic addition, and it is always the first step is considered. So the first step is a nucleophilic addition, so that this reaction is considered as the nucleophilic addition. Nucleophilic addition. Now it is a slowest step. So the first step is a slowest step and it is considered as the rate determining step. So that is step 1 is slowest step, then it is considered as rate determining step. Rate determining step. That is, the rate of the reaction is dependent only the first step, not the second step. Now consider aldehyde and ketone. Aldehyde, it is R bond C double bond O under that H. Now ketone R bond C double bond O under that R. Now among these, which one is more reactive towards nucleophilic addition? So the nucleophilic addition is nothing but the electromeric effect, that is negative electromeric effect, and which one has faster to nucleophilic addition? Now we may consider the aldehyde, it is aldehyde, and in aldehyde what will happen? The oxygen is highest electronegative, so that the pi bond will move towards that oxygen. Now this carbon getting a positive charge and oxygen getting a negative charge. Now what will happen? It is R group is electron donating group and plus I group, and it will be moved towards that carbon. Now in the case of ketone, what will happen here? In ketone, the same way the pi electron will move towards that oxygen, and here there are two plus I groups, plus I group, and here also plus I group. So the covalent bond is moved towards the carbon, and here also it will be moved towards the carbon. Now what will happen here? The positive charge in ketone is somewhat decreases by that the inductive effect, so that the rate of the reaction towards nucleophilic addition is decreases. So in the case of ketone, the positive charge of carbon, positive charge of a carbon decreases because of inductive group, so that towards nucleophilic addition, the ketone has lesser than that of aldehyde. So aldehyde has maximum or greater nucleophilic addition than that of ketone. So towards nucleophilic addition, aldehyde has faster than that of ketone. Okay. Now, what is the difference between inductive effect and electromeric effect? Listen. Here, the first difference is in inductive effect, the sigma bond is transferred. So here, the transfer of sigma bond is transferred. But in electromeric effect, here there is a pi bond or delocalization of pi bond. Delocalization of a pi bond. Now, here the inductive effect is a permanent one. It is a permanent effect. And here it is a temporary effect. Electromeric effect is temporary effect. And the third one, here in inductive effect, only partial charges are created. So here partial charges are created. Partial charges like del plus or del minus, that will be created. So it is created only the partial charge. But here transfer of pi electron or delocalization of pi electron. So here there is the net charge. So net charge is created. So these are the difference between inductomeric effect and electromeric effect. Now, dear students, we discuss the electromeric effect and difference between inductive and electromeric effect and go through your NCERT book. Thank you.